I got the battery swapped out here, and the other ones are over here. I didn't quite like how the thing was 30 volts, but I thought that was kind of strange why this thing would be sitting here at 30 volts. I'm gonna take a look at it again and see if it's reading something weird like that. I don't really trust this. This crap here. I really regret buying THHN wire from Santan Solar. It's been nothing but a pain in the ass because it doesn't flex very much. So you got to finish this stuff here. Okay. So let's see. It goes to sleep. It doesn't stay on, which is great. Yeah, so it was like at 30 when I checked it earlier. 29.2, would be, what is that going to be for each battery? I don't know. I should probably test each battery with the meter just to kind of get an idea. But 14.6 volts, something like that. Yeah, so their little nifty manual has a nice little chart in the back of it. So it doesn't even have that voltage in there. It's kind of strange. Interesting. So I wonder if these are just overcharged on that. I wonder if I'm going to run into a problem. I need to check and see if all my stuff is set correctly. I seem to remember there was an issue with that other one, but that's been charging that battery there. I haven't run into the voltage being that high ever on the other battery. Well, we're not using a 25.6 volt battery pack, we're using two 12.8s. So their charging voltage limit is still pretty much the same though. It'd be 28.4. I think it's way too high. Yeah, so I just looked in here. There was a whole bunch of stuff that was set really wrong. So the limit voltage was at like 29.9 or something ridiculous. So it overcharged the battery basically. So they want it to be 28.4, which is normal. The over voltage disconnect. That particular inverter doesn't really have a setting for that. It just has a limit for the voltage charging. And then the float was in the wrong thing. It was 28 something. So we set it to that. And then you're able to adjust the low voltage disconnect and the reconnect and the warning. So set all those. So it should be good. This older inverter is kind of hard to configure, but basically right now I've just turned on the inverter to put a load on it. There's not really anything going. And so it's reading 28.5 now. So I'm going to let it do a little consumption and just let it sit there and idle consume. Get rid of any of that excess overcharge. So 28.5 still wouldn't really be on their particular state of charge chart. I'm not really sure. Their voltages are strange. So it seems like it should be higher, but I can't remember. So we got this other one here. I didn't have room for everything, so I put the circuit breaker over here. I put this over here, and that over there. This is under load, and you can see there's 26 amps. Now with this shunt, you have no idea if it's going in or out. That's the problem. And then if you calibrate this, you might get accurate readings. But right now I can see 36 amps is its output for the battery, basically. So there's 10 amps somewhere else unaccounted for. It's probably on one of these. So we get 7.9. There we got 0.7. So something isn't exactly the same, but holy hell, 7.15 kilowatt hours for the day. I don't know, I don't remember that high of a number being on there. So this is only putting out 500 something watts right now because it's starting to get, the sun's setting. So we're only doing that, and our load is 1.3. We've got grid assist, where you see that it's actually doing anything right now. So when the battery gets to a certain level, then the grid will kick in. So right now we're using whatever's stored up in the battery. So the hope is that this will sit here and run, and then once the battery reaches a certain point and there's no more solar, that the grid will kick in, which will top off the battery and run everything until the time that this is set to turn off. So I have this set to turn off at 10 o'clock at night, at which time then I switch over to that. But it's kind of a complicated experiment. So I have not tried this particular battery on this inverter, and I need to check to make sure I have the settings on this, because I was using this with lead acid batteries. So this one is a pain to set also, just like that one. You got to go into a bunch of menus, and most of everything doesn't really make sense. So anyway, we're going to see how this does. I've followed their stuff to the T on those batteries, and what I actually could probably do is pull one of my air conditioners off of this one and plug it in here and just start using this one. So now we're at 28 volts. That looks a lot better. 27.9. I thoroughly believe this thing's been overcharged. So what I'm actually going to do is I'll go ahead and undo my air conditioner out here. And I'm going to plug it into this. We'll put a load on it. Okay. And now we're at 27.8. According to them, this battery, fully charged, should be 13.4, which would only be 26.8. So I don't know without doing my research, but to me that sounds wrong, but I might have it confused. So anyway, we want to put this under a load, and then by doing that, once it gets to a certain voltage, so the voltage is too high right now, so the solar isn't going to start doing anything. You see it's there, but it's not connected. But once this thing kicks in, and that thing starts drawing like 8 amps or 6 amps or whatever it draws at 120 volts, it's going to take a lot more than that to convert that. Right now, there's nothing coming in on solar. We're pulling 3 amps out of the battery, and according to them, that's 90 watts. and the load is 0.7 amps right now. But like I said, once it kicks in, it will be a lot more. It shows you what the inverter's load is, 80 amps. And then these are just firmware things. We can totally hear the radio behind me picking up the noise. So 3 amps output from the battery. So this is all battery right now. And what's annoying is, like, there is solar hooked up, so I'm going to deplete my battery. You know, meanwhile, so that's why I don't like the way that this inverter works. It kind of like doesn't start charging the battery until the battery is too damn low. But they don't sell this one anymore, so you don't really need to worry about that. So the air conditioner is really annoying because it takes a couple of minutes for it to restart. So anytime that you have bad solar or whatever, bad conditions, when the inverter is going on and off, so then now you end up sitting there waiting for 5 minutes for the air conditioner to come back on, and it just kind of becomes a nasty cycle. Okay, so we see it's pulling. There was a surge there up to like 7 or 8 amps, which isn't too bad. And now we're probably going to pull about 6.5, and that's probably where it'll rest. Okay. And that ends up being 760 watts or kilovolt. Yeah, 750 watts out of the inverter. It is nice, it shows you that. So now our voltage sagged down to 26.2, 26.1. It's interesting though, it seems like solar should be charging. So it's pulling 32 amps out of this battery right now, which is quite a bit. So if I remember correctly, because it's just, I've been so long since I've really been paying attention to this, so now our solar kicked on. So the output of the battery should drop from 32 amps to something else. That LED is like really overpowering. I think this air conditioner draws 30 amps on a 24 volt system, and the other one draws 20. So when they're both running, I'm drawing 50 amps at 24 volts, so about 1 point something kilowatts. So you see that we're a little over 800 watts out of the inverter. 6.2 amps load. And let's see. So we're at 26 watt, 120 volts. There's 42 volts from the solar, but the output is like nil. So probably a little too shaded. So we have 0 significant input. So anyway, guys, I'm hoping I got it set correctly. We'll just let it run for a bit, and hopefully I won't need it tonight.